Article 230.70A of the National Electrical Code states that service disconnecting means shall be readily accessible. They shall be installed at a readily accessible location either outside a building or structure or inside nearest the point of entrance of the service conductors. Article 230.70C states where service equipment is located inside a building or structure, it shall be accessible without removing any part of the building or structure or requiring the use of tools. Based on these National Electrical Code interpretations, having an outdoor service disconnect at the meter allows for an indoor load center without any regard to the distance from the point of entrance of the feeder. In this situation, a 4-conductor feeder is required to be run to the load center. This includes 2 hot conductors, 1 neutral conductor, and 1 grounding conductor. The outdoor service disconnect must be grounded and bonded in accordance with the National Electrical Code. This includes connecting the grounding electrode conductor to the service enclosure and grounding the neutral conductor. The National Electrical Code interpretations and requirements are generally applicable. However, local codes and regulations may vary, so it is always recommended to check with local authorities for any specific requirements. The service disconnect must be readily accessible. This means it must be located where it can be easily reached without obstruction. Installing it outside or inside, nearest the point where the service conductors enter, fulfills this requirement. If the service equipment is inside, it has to be accessible without needing to remove any part of the building or use tools. This ensures that in an emergency, the power can be shut off quickly and safely. The use of an outdoor service disconnect at the meter provides flexibility in locating the load center. The distance between the point where the feed enters the building and the load center becomes less of a concern. This setup requires a specific type of feeder wiring. A 4-conductor feeder is necessary. This feeder consists of 2 hot conductors, a neutral conductor, and a separate grounding conductor. This configuration is crucial for safety and proper operation of the electrical system. Grounding and bonding the outdoor service disconnect is critical for safety. This involves connecting the grounding electrode conductor to the service enclosure. Additionally, the neutral conductor must be grounded at the service disconnect. These measures help to prevent electrical shock and ensure the proper functioning of overcurrent protection devices. It is important to verify local codes and regulations. While the National Electrical Code provides a comprehensive set of guidelines, local jurisdictions may have additional or more specific requirements. Always consult with local authorities to ensure compliance with all applicable regulations. The purpose of a service disconnect is to isolate the building's electrical system from the utility's electrical supply. This allows for safe maintenance and repairs to be performed on the building's electrical system. The service disconnect is typically a switch or circuit breaker that can be manually operated to cut off power to the building. The location of the service disconnect is important for safety and accessibility. It should be located where it can be easily reached in an emergency. It should also be protected from damage and unauthorized access. The size of the service disconnect is determined by the size of the service conductors. The service conductors are the wires that connect the utility's electrical supply to the building's electrical system. The size of the service conductors is determined by the building's electrical load. The electrical load is the amount of electricity that the building is expected to use. The grounding electrode conductor connects the service equipment to the grounding electrode. The grounding electrode is a metal rod, pipe, or plate that is buried in the ground. The grounding electrode provides a path for fault current to flow back to the source, which helps to protect people from electrical shock. Bonding is the process of connecting all metal parts of the electrical system together. This includes the service enclosure, the grounding electrode conductor, and a metal conduit that contains the service conductors. Bonding helps to ensure that all metal parts of the electrical system are at the same electrical potential, which reduces the risk of electrical shock. The neutral conductor carries the unbalanced current from the electrical system back to the source. The neutral conductor is typically grounded at the service disconnect. Grounding the neutral conductor helps to stabilize the voltage on the electrical system and reduce the risk of electrical shock. The two hot conductors carry the electrical current from the source to the building's electrical system. The voltage between the two hot conductors is typically 240 volts in a single-phase system. In a three-phase system, the voltage between the hot conductors can be 208 volts or 480 volts. The four-conductor feeder provides a complete path for electrical current to flow from the service disconnect to the load center. This includes two hot conductors, one neutral conductor, and one grounding conductor. The grounding conductor provides a path for fault current to flow back to the source, which helps to protect people from electrical shock. The load center is the point where the electrical power is distributed to the various circuits in the building. The load center typically contains circuit breakers or fuses that protect the circuits from overloads and short circuits. The National Electrical Code is a set of standards for the safe installation of electrical wiring and equipment. The National Electrical Code is updated every 3 years. It is important to follow the National Electrical Code when installing electrical wiring and equipment to ensure safety. Local codes and regulations may vary from the National Electrical Code. It is important to check with local authorities to determine the specific requirements for your area. Consulting with a qualified electrician is always recommended when working with electrical wiring and equipment. A qualified electrician can ensure that the electrical system is installed safely and in accordance with all applicable codes and regulations. Understanding the National Electrical Code requirements for outdoor service disconnects and indoor load centers is essential for ensuring the safety and proper functioning of electrical systems. The information provided covers key aspects of these requirements, including accessibility, feeder wiring, grounding, and bonding. By following these guidelines and consulting with local authorities and qualified electricians, you can ensure that your electrical installations are safe and compliant with all applicable regulations. The role of readily accessible service disconnecting means is to provide a way to quickly and safely to energize the electrical system in case of an emergency or for maintenance purposes. The requirement that service equipment located inside a building be accessible without removing any part of the building or using tools is to ensure that anyone can easily access the equipment in an emergency, even without special tools or knowledge. The flexibility in locating the load center when using an outdoor service disconnect offers several advantages. It can simplify the wiring layout, reduce the length of feeder conductors, and allow for more convenient placement of the load center based on the building's design and usage. The four-conductor feeder system is crucial for providing a safe and reliable electrical supply. The two hot conductors carry the current to the load center, the neutral conductor provides a return path for unbalanced current, and the grounding conductor provides a path for fault current to flow back to the source, minimizing the risk of electrical shock. Grounding and bonding are essential safety measures that protect people and equipment from electrical hazards. Grounding provides a low-impedance path for fault current to flow back to the source, causing the overcurrent protection device to trip and to energize the circuit. Bonding ensures that all metal parts of the electrical system are at the same electrical potential, reducing the risk of electrical shock if someone comes into contact with two different metal parts. While the National Electrical Code provides a comprehensive set of guidelines, local codes and regulations may have additional requirements or modifications. It is essential to check with the local authorities to ensure compliance with all applicable codes and regulations. This may include obtaining permits, inspections, and adhering to specific requirements for grounding, bonding, and other aspects of the electrical system. The service disconnecting means should be clearly marked to indicate its purpose and function. This helps to ensure that anyone can quickly and easily locate and operate the disconnect in an emergency. The service disconnecting means should be located in a place where it is protected from physical damage and environmental conditions. This helps to ensure that the disconnect remains operational and accessible in all conditions. The service disconnecting means should be installed in accordance with the manufacturer's instructions. This helps to ensure that the disconnect is installed correctly and will function properly. Regular inspection and maintenance of the service disconnecting means is essential for ensuring its continued reliability and safety. This includes checking for any signs of damage, corrosion, or loose connections. The service disconnecting means should be tested periodically to verify that it is functioning properly. This can be done by a qualified electrician. The electrical system should be designed and installed in a way that minimizes the risk of electrical shock and fire. This includes using appropriate wiring methods, grounding and bonding techniques, and overcurrent protection devices. The electrical system should be inspected and tested by a qualified electrician before it is put into service. This helps to ensure that the system is safe and will function properly. The electrical system should be maintained regularly to ensure its continued safety and reliability. This includes checking for any signs of damage, corrosion, or loose connections. The electrical system should be repaired by a qualified electrician. This helps to ensure that the repairs are done correctly and safely. The electrical system should be upgraded as needed to meet the changing electrical needs of the building. This may include adding new circuits, increasing the size of the service conductors, or replacing old equipment. When working with electrical wiring and equipment, it is important to follow all safety precautions. This includes wearing appropriate personal protective equipment, such as gloves and eye protection. Before working on any electrical equipment, it is important to de-energize the circuit. This can be done by turning off the circuit breaker or removing the fuse. It is important to use the proper tools for the job. This helps to ensure that the work is done safely and correctly. It is important to follow the manufacturer's instructions when installing or repairing electrical equipment. This helps to ensure that the equipment is installed correctly and will function properly. It is important to have a qualified electrician inspect the work after it is completed. This helps to ensure that the work was done safely and correctly.